Today we're going to look at the domain and range of rational functions. Keep in mind rational functions are ratios, they're fractions with polynomials in the numerator and denominator. The domain is a description of what can you put into this function, what's going to give you a valid output. And the range is, well, what kinds of outputs are you dealing with here? When I think about the domain and range of rational functions, I think about the story of Adam and Eve. Adam and Eve were told you can eat of absolutely any fruit except the fruit of the tree of life. So if you think about their diet as a set of values, it was nearly infinite except for one excluded value. Likewise, the domain and range of rational functions is nearly infinite except for some exclusions. Well, what are those exclusions? The asymptotes. Let's talk about domain, the x values. If we're talking about x values, we need to think about vertical asymptotes. Vertical asymptotes come from places where your denominator is equal to 0. So in this case, the only vertical asymptote of this function is the vertical line x equals 3. So the domain is everything else. 3 is the only x value that you can't put into the function. Put it in, you would get this. 3 plus 2 is 5. 3 minus 5 is negative 2, divided by 3 minus 3. You can't divide by 0. It's an undefined value, meaning we literally don't have a definition for what it means to divide by 0. Okay, so the domain of this function is from negative infinity to infinity. From negative infinity up to the x value 3, and also anything bigger than 3. A couple of quick notes. This is a capital U, it stands for union. It means and also. Keep in mind that for both domain and range, it's always going from the smallest value to the largest value. So for domain, I like to think of that as left to right. For range, that would be from the bottom actually to the top. Let's talk about range. To talk about range, we need to talk about horizontal asymptotes. Okay, the degree of the numerator is 2. If we multiply this out, there would be an x squared. The degree of the denominator is that unwritten exponent 1. When the degree of the numerator is greater, there is no horizontal asymptote, which means no y values are restricted. The range of this function is any y value from negative infinity to infinity. Let's take a look at 2 more examples. Domain, x values. Let's think about our vertical asymptotes. It's kind of hard to tell here because the denominator isn't factored. So let's go ahead and put those terms in order and then factor the denominator. They've both got an x. I'm going to take out a negative x to make that 4x, the first term in my parentheses, positive. And what I notice is there are 2 factors here, a negative x and a 4x minus 3. Well, my vertical asymptotes are going to come from where either negative x is equal to 0 or where 4x minus 3 is equal to 0. So I've got 2 vertical asymptotes, one at 0, one at 3/4. My domain has to be written in order. So if you're thinking about a number line, the number 0 comes from the number 3/4 because 3/4 is positive. So my domain is everything except these x values. It's all the way up on the left up to the x value 0. And between the x values 0 and 3/4 and everything to the right of 3/4. If it helps you to see it on the number line, think about taking these 2 values out and shading absolutely everything else. Everything from the left up to the x value 0, everything between these x values, and everything to the right of the x value 3/4. Let's talk about range. To talk about range, we got to talk about horizontal asymptotes. The degree of the numerator is 1, easy to see here. The degree of the denominator is 2. When the degree of the denominator is greater, there's a horizontal asymptote at y equals 0. So that's the one y value you're not going to get out of your function. My range is from negative infinity up to the y value 0 and anything bigger than 0. Last one. Check out the domain and range here. You know the drill by now. Let's start by talking about what's not in the domain. Well, the vertical asymptotes are going to come from where 2x plus 3 is 0 and where 4x plus 7 is 0. So the two x values you're not using are negative 3/2 and negative 7/4. This, for the record, is negative 1.75, I think, and this would be negative 1.5. If we put them on a number line, that helps me get it in order. This domain has to be written from least to greatest. Okay, negative 1.75 is a smaller number. So we're going to use all the x values except these two. Our domain is going to consist of these three intervals, from negative infinity up to the x value, not including, that's why I'm using parentheses. Otherwise, I'd be using those square brackets. All the x values between those of my vertical asymptotes, and anything to the right of the x value, negative 1.5. What about horizontal asymptote? Well, if we multiplied these out, I'd get negative x squared plus blah, blah, blah. I'd get an 8x squared plus blah, blah, blah. And I'm really only looking at these first two terms because I'm thinking about their degree. Since their degree is the same, the horizontal asymptote is the ratio of their leading coefficients. It's y equals negative 1/8. That's the one y value I'm not going to include in the range. So the range is from negative infinity up to the y value negative 1/8, and also from the y value negative 1/8 all the way up to positive infinity.